is conventional drilling technology, a robust and simple principle that has been successfully used for decades all around the world. But the Barents Sea is demanding. It requires improvements to be made to those conventional drilling methods. The area is commonly known to be full of potential loss zones, and the remote location, combined with weather conditions, increase the costs and consequences if mud loss occurs whilst drilling.
So the Wisting Project is a very important project for OMV in Norway. This is the first project we have operated for, and it's also far in the north in the Barents Sea. So it's only the best of the best that can do. So a part of that project is the drilling of the wells, and this is where Reelwell comes in. And Reelwell, I hope, can make this a more robust project by its technology advances, but also hopefully a safer project. So I'm really looking forward to the results of this project.
Now we are here at Ulrig, a research center just outside Stavanger, together with our partners Reelwell and Halliburton. What we are doing here now, we are using a different drilling methodology than the traditional, where we focus on the energy. This new drilling methodology allows us to reduce the energy we put into the well. What we want to achieve is really to avoid drilling fluid losses that can lead to well control issues, and will also increase the time we need to spend drilling these complex reservoirs. Further, we see that if we can drill long horizontal sections, that will contribute to the overall well count on Wisting. We will have to challenge drilling through a lot of different compartments and faults, which is a complex situation for us. But if we can succeed with this low energy drilling methodology, yes, we can also optimize on the well count.
Mud loss is one of the largest risks associated with drilling at the Wisting field. With a narrow wait window and potential weak formation, it is important to reduce any stress to the formation in order to avoid problems such as lost circulation, formation damage or stuck pipe scenarios. Controlling equivalent circulation density, or the hydraulic force that the formation is exposed to, is crucial to ensure that wells can be drilled in a safe, reliable and cost-effective manner. One of the methods that can solve these challenges is the Reelwell drilling method, or RDM. The RDM is based upon a dual drill string, where mud is pumped down into the annulus of the pipe and the returns are taken in the inner pipe instead of being flushed back to the surface outside the drill pipe, as in conventional drilling. The system also allows the use of one or two different muds. The active mud is used for circulation and to bring cuttings out of the hole, while the passive mud in the annulus is static and is only used to control the well. Hole cleaning is achieved at low flow rates, and the method enables a constant downhole pressure throughout the entire well length during drilling. Torque, drag and mechanical forces to the formation are also reduced compared to conventional drilling. And furthermore, it increases the potential of drilling longer reservoir sections. If this method turns out to be suitable for the Wisting field, we will have reduced the risk for mud loss. And this will, in turn, create a significant reduction in time and cost.
The key thing has really been also...
This well has been simulated before we started to drill it. And so far, it proves to meet the design criteria. We are able to keep all the drilling parameters very constant, no fluctuations that will have a negative impact on the performance. Everything is within our simulations. We have focused a lot on cost and cost reduction results based on this drilling methodology. But every drilling operation has also a safety aspect to it. This drilling methodology, if we succeed, we will enhance the safety of the well. The next step for us will be to go into an in-depth analysis of all the data collected measuring it against our well objectives, and continue to evaluate if this is the correct drilling methodology for the Wisting field development.
This has been a very unique cooperation. In the project we've had academia represented through IRIS, we had the service contractor through Halliburton, and of course ourselves as the operator OMV. I think together we have really worked on developing this technology in a good way, and I think it will, and I hope it will have a big impact on Wisting, but not only Wisting. I actually expect this to be very useful and open opportunities on the Norwegian continental shelf, but even globally.